Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video we'll continue to learn about time in Pandas. Specifically, we'll look at what is epoch timestamps and how to create them, and look at what is the effect of floats in the precision when we create a timestamp. Next, we'll look at how to convert a timestamp back into epoch, which is either seconds, nanoseconds, and then how we can use the origin as a parameter while we are creating the timestamps, so we can change the time of origin. So let's get into Jupyter notebook and start coding. Here I've already created this new notebook and imported three libraries: numpy, pandas, and datetime. So the first item that we'll look at now is epoch timestamp. If you remember, epoch is the beginning of time. So Unix epoch would be January 1st of 1970. Here first we'll create now timestamp. So pd dot timestamp dot now. So this is at the time of recording, this is the time, and we'll get the value. So this is the nanoseconds that we have, and from this is now the epoch. So times elapsed since January 1st of 1970, and we can convert this to a timestamp. So using pd dot to underscore date time, and within this we can specify this entire number and then specify the unit. So the default is nanoseconds. So when we run this is the actual nanosecond value. However, we can go ahead and change this, and let's create a second. So remove this 3, then 6 and 9, and when we run this, now we have the timestamp created with only up to second resolution in time. Next, let's look at how we can convert a naive timestamp into time aware timestamp. So let's say here naive versus aware timestamp. So naive, as you've probably known from the previous video, would not have a time zone associated with it, whereas the aware would have a time zone associated with it. So sorry about that. pd dot to underscore date time, and in here we can specify the same I'm going to use the same string, right, that was here, this number, and then specify unit is equal to s. So when we run this, we can see that there is no time zone associated with it, and that can be changed when we add dot tz underscore localize, and here we can specify tz is equal to utc, capital U, capital T, and capital C. So now we see that in the data type we have the UTC, which is the coordinated universal time added. So this time stamp is now time aware. Next, let's look at precision and how does float affect the precision of a timestamp. Let's go ahead and create a new timestamp now. So timestamp dot now dot value, and I'm going to copy this and create pd dot to underscore date time, and here we specify this, and then unit is equal to nanoseconds. So as you can see, we have a nanosecond resolution right here, 444801. Now if I copy this entire thing, and instead of nanoseconds, if I just specify seconds and remove 1 2 3 4 5 6 7 8 9. Then as you can see, of course, the precision is not there, but then within this, if we specify a decimal here, and if I were to go ahead and remove these, then what you can see is there is a difference in the numbers that we see after the decimal. So if I go ahead and remove more of these, so as you can see, these become zeroed out, where so if the more data you have after the decimal, the better the resolution is. And so if you do not have that data, then this just becomes 0. So for the epoch time that is stored, is usually can be stored in int64 data type. Next, let's look at how we can convert timestamp back into epoch. So timestamp to epoch. So by epoch, what I mean here is just the number of seconds or nanoseconds elapsed since 1970 January 1st. So if we have a timestamp, let's create a timestamp TS and pd.timestamp using a string 2020-07-13. And so this is our timestamp, and if we want to convert it to epoch time, so we can do is TS minus, we need to subtract the timestamp for the origin, which is 1970-01-01, and then divide this floor divide, so 2 backslash by 1 second. So pd dot time delta of 1 second, and when we have this is the number of seconds that have elapsed since the epoch, since the origin. So that's the epoch. And to check that this is correct, what we can do is go back and convert it. So pd dot timestamp and specify the seconds there and specify unit is equal to seconds, and that's what we get. So we get the same date that we started with right here. There is another way we could have done this, is just simply saying ts.value, and that would have given us all the nanoseconds, and if you divide that by 10/9, then we get the seconds which we had above. Finally, let's look at how we can use origin as a parameter while creating timestamp using to_date_time. So using origin as a parameter, so pd.to_date_time, and let's say we have 15 and then 150, then 123, 123, and unit is equal to seconds. So that's the timestamp we have. Now to this timestamp, if we copy paste it here and specify origin is equal to pd.timestamp, let's say if we go back in time, so 8110-01-01, then we get this new timestamp where the origin we have set it to 1800s, whereas here above the origin that we had was the default origin timestamp, which was 1970-01-01. Sorry, timestamp, and so that's the difference right here. Based on the need of the data, you could go ahead and change the origin of time while creating timestamp. That was it for this video. I hope in this video you learned what is epoch and how to convert epoch into timestamps and timestamps back into epoch, and how we can use origin as a parameter to change the origin date while we are creating timestamp. In next video we'll continue this discussion in time and look at few more additional features that Pandas offers to work with time data. Please like, share and subscribe. I hope to see you all in the next video. Thank you.